Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. Dear students, in last video we talked about the project management, and therein saw a lot of concepts and then the basics of project management, and then we arrived at a point where we were talking about network analysis, which actually give us those techniques for the project management, where we can do planning and management and control of the projects. And then we saw last time an example, and the things we need in a network diagram is the arrows, okay, with the direction which indicates an activity. Then there are the nodes, which we also call as an events. And then activity is something which does some work in a project, some kind of a phase in your project. And then there are also dummy activities. We come to this dummy activity a little later. Okay, now this is an activity. One second. Okay, so you have some kind of an activity from node 1 to node 2, then from node 2 to node 3, and another activity, which activity is something which requires some time and resources. This is something, the job you do in a project. And then there are events, and events are nothing where the activity starts or finishes. They are shown by the circles, right? We call them as an event. Either the activity starts from an event and it leads to the event when it finishes. The activity, this is activity. When it finishes, it leads to an event. Okay, and then there's a network diagram where we arrange these activities and events and their costs and all. This is called as a network diagram. In a network diagram, we have concept of critical path. A critical path is the major path, okay, in a network diagram, which has the longest path, because it gives an estimate of, when you talk about the longest path, then the shortest paths are also there, but the longest path will give us the what we call as a critical path, because it determines the minimum time in which the project may be completed. Okay, because we are talking about all the long arrows or long costs. For example, we show it using the bold arrows. Okay, 1 2 4 6. Say for example, depending on the cost, actually not just any arrow, depending on the cost, which is the longest paths, we choose all the longest paths. This gives us a critical path. We'll see this later in detail also. Then the critical activity are the activities which belong to this critical path in a network diagram. This is the last time example we were talking about, but before we go for this, we need to know one more concept that's called as a dummy activity. So what is a dummy activity and why we need it? Dummy activity. So if we have a situation like this, that we have an event, okay, and then there is an activity, there is second activity which lead to the same event. 1 2, say this is activity A, activity B, but in network diagram this is not allowed. Okay, so these are not allowed, where one activity can have two activities lead to the same event or node. This is not allowed in my network diagram. So what we do to break it, we apply the dummy activity. What we do is we say this is 1, okay, and this is my another node 3, and this is my another node, say for example 2. Okay, 1 2 3, and this is my A and this is my B, and then I use the dummy arrow. This is called arrow. I use the dashed lines, okay, to show my dummy activity. So this is dummy activity. This one is the dummy activity from 1 comma 2. Okay, so this is the dummy activity, basically 1 comma 2, which has no cost attached to it. So this is how we solve this and make it more representable in our network diagram. So we are having a node which has where we have a common beginning and end points. Common beginning and end points of two activities. If this is a scenario, we break that into we create a dummy activity, so that not to show two activities focusing on a single node. I was writing out of the screen, so here it is. This is a dummy activity when I have the dashed lines. Okay, it was going out of the screen, so let me get it here. Now, why we do this? Because it's difficult to conduct computation and network loses its uniqueness in its identification. So we such inconvenience causes frequent mistakes during network analysis. Therefore, we have to apply the dummy activity to consider it two different activities. Okay. Now, if you look at this diagram here, where we have the activities and we want to make uh, the network diagram, and I'm seeing that we have the activity A doesn't have a predecessor, activity B doesn't have a predecessor, so I create a node 1 and create an activity A which can lead to the node 2, and because B is also not having a predecessor, so that means it starts from the same node and it goes along and go to the node 3. Now these numbers 1 2 3 are arbitrary. You can write anything and you can change them later, because sometimes if it is a dummy activity we have to change them. And then when I say C, the C is an activity which determines personal requirements. Its predecessor is B. That means the C has to start from the node 3 because the B ends there. It cannot start from 2. So we have to see what's the predecessor. Now, if you see the D here, the design facility, its predecessors are A as well as C. Now, here is some complication here, because the predecessor of the D design facility is A comma C, both A and C. Now, what is the problem? Problem is that D's predecessors are A as well as C. So that means D has to start from either C or A, because it's predecessor. So should I show it, should I show this from here or should I show it from here? That is my the D, but I cannot show it twice. That is a problem. I cannot show it twice in a network diagram. So I have to combine these two. Okay, I have to combine these two into the one node, which will then lead to the D, right? Now, what we have done is we have combined the 2 and the 4 into the node 3, and now we added the D, right, which is having a common predecessor A and C. As you could see, immediate predecessors are A and C. Now they both have the A and C, and it leads to the another node or event 4. That means completion of D, right, after A and C both happened, because D also should you can start the activity D only when A and C finishes. So there's the only way that we have to do it is we have to combine these two into the one, and then D starts from that and leads to the node 4. Now if you say E, so our E is a construct interior, it is immediate predecessor is D only, so there is no problem with E. We can start it from the D, because when the D finishes, E starts, right, and leads to the node 5 and event 5, the completion of activity E. Now here another problem arises, which is now when we try to go for F. Now F has a predecessor C, okay, so that means C is here, so I have to make the F here, and this is the node 6, and this is telling us that F has a predecessor C, but it gives us the wrong information here, that A is also the predecessor of F, which is not in my table, right? So it gives us a wrong information that A is the predecessor of, which is not there, because F has only one predecessor, that is C. So here I have a problem and I need to solve it. Here what's called as a dummy activity comes into. Now what is a dummy activity? Which will solve me this diagrammatic dilemma, okay, which is we introduce another activity which is by the dashed lines, okay, which is just for a pedagogical, which will act as provides a pedagogical device, so that we can draw our network representation correctly, and it does not have any cost attached with it, a cost in terms of time or resources. It will not have those things attached in it. It's only for the diagrammatical representation, the dummy activity, which in nutshell we can say it will save us from this situation. So this is what we do. We introduce a node 4, okay, and then attach the dummy activity with the 2. Now if you look at it, if you look at this diagram, we have the D which has a predecessor A and C. Okay, so it is telling us that its D has a predecessor. That means when the A finishes, if you go this way, then you can do the D, the A. But if you go from the B, you have to go from B, C, and this way, okay, to go to this D. And it has no cost attached to it. Say for instance, this is 3 cost, this is 2 cost, and 4 cost. Say it is 3 cost, was 2 cost, and 4 cost, for example. So if you go to D via 1, 2, A, B, and C activity, so total cost will be 2 plus 4, 6, okay, to reach here. And if you go this way, then the cost is 3. But same scenario happens here also, because if you go to the D from the A, the cost is 3. But if you go this way, the cost is 2 plus 4, that is 6, because it has no cost attached to it, so cost remains same. But for the F now, the predecessor for the F is only C. So we can see here the predecessor for F is only C, not the A. So that thing is fixed here, right? So we do not have for the F the predecessor A, we have only the B, only the C, the predecessor. So that thing is fixed now. Now this is my diagram to consider other nodes also here. So we have to go for, after F we go for the G and H, and I'm seeing G and H both have the F as a predecessor. So G and H both lead to the same activity, to the event 7, okay, and they have both have the predecessor F. So F leads to the 6, so that means for G and H the initial starting node have to be 6, and it leads to the node 7. Okay, then if you see I, which is again a problem I will tell you, and then there is an I, that is make financial arrangement with institutions to whatever, so that has the B as the predecessor. So I has the predecessor B. Okay, so that means I has to start from the B. B is here, its predecessor is B, that means node 3 is the starting for the I, and it leads to some node. Okay, and this is gonna be my last node, because J after that, which has the predecessors H, E, G. So that means H, E, and G, they are leading to this node, right? So that means here starts the J and ends with the last node, because after that nothing, so it has to end with the terminal. So this is a terminal node or end node, and this is the start node, right? But now I am having a problem here. Even though its network diagram is good, but for computers it's not good, because sometimes the activity is shown by, if I have to show activity H, how I will show it in a computer, I will use these nodes, I will call it 6, 7. And if I have to represent G, okay, it will be also represented by 6 and 7, because computer represents it with the start and end node. So if you see H, what is the start node? 6. What is the end node? 7. What is the, for G, what is the start node? 6. What is the end node? 7. So for computer these both are same. It will not, it cannot differentiate the two, because both have the start and end point same, right? So that is why we do not allow these parallel activities which has the same starting point and same end point in our network diagram. So we have to fix it. So again, what we use, I told you in the beginning of dummy activity that we again use the dummy activity to solve this situation. So how we do it, we can introduce here some dummy activity. Say this is node 6 and it goes to the node 7, for example, okay, right? And then from here I create an event, say for example 8. Now this is my what's called as a higher, that is G, this G higher, and from here I will use the arrows, because G and this should be same as here. I will not add any cost here, any time or resources here, so it is same as this. But here as a representation, this will be 6, 7, and for this will be 6, 8. For G it will be 6, 8 representation now. Sorry, this one is G68 and 67. So computer can identify this as, these are actually different activities. And now it will, the dummy activity will have no effect because there's no cost with it. It will be 0 cost. So when it will add, when you add to the in the PERT or CPM, then it will have no effect, right? So we can fix. So what I have done here is I have created here a dummy activity, and there is a G going to the node 8, and this one goes to the dummy activity goes to the 7. It has no cost attached to it. And if you talk about the 7, the predecessors are G and H, which is as per our diagram. Then it leads to the 9, and 9 here is having the same situation, because the 7 was having the predecessor, the J is having the predecessor G, H, and E. That information is also stored. So this gives me a complete picture here. If I just go a little up to see my diagram here, okay. So I'm seeing the A. One second, a little down. It's getting too much down, too much up. One second. Let me get it stepwise. Okay. Now we got the A. Select office site. That is having no predecessor, so that means a beginning node. B is also having no predecessor, so it's again a beginning node. Okay. Then what you do is, then you go to the node 2, or if you see C, its predecessor is B, so you have a C, its predecessors are B, so you have to start from here. And then you say D, design facility, it is predecessor A as well as C, so you say D, its predecessors are A as well as C. We introduced the dummy node here, we discussed that. You can rewind the video and just see it, what was that. Okay. Then after that, we got the E, the predecessor of E is D, so this is the E, the predecessor of this is D, so it comes from here. And then F, select person to move, its predecessor is C, so F has a predecessor C, so it comes from here. Okay, that's why we introduced this, so that if we combine the node, if we did, then F would have the A as well as C predecessors. So we said no, break it into the dummy activity, so that F will only have the C predecessor. And after F there is G and H, both have the F predecessor, so we said the G and H, we again broke it into the another node 8, so that it will not have the same predecessor, same node from the beginning and the end. So we broke it, because I told you the computer will not then identify which is G and which is H, because the 6, 7 and 6, 7 would have been for the both G and H as an identification, but we broke it, so H can be identified as 6, 7 and G will be identified as 6, 8, and we have a dummy activity, so it doesn't matter for us because it adds nothing to it. Then we move on to the I, which has a predecessor B, so here is an I which is a predecessor B. Okay, financial arrangements. And there is a 9 node, the last one is a terminal node, where I say, because this is a J which is ends at H, E, and G, so it has to be predecessors of H, and E and G has to be predecessor of this J, and it ends with the last node. Now we have done the network diagram, and now we have to go for the PERT and CPM, but this so that is what we do, what's called the network analysis. We have to go for, we have to calculate the critical path in our diagram, and we need to know these all terms before we can jump into the examples of PERT, etc. Okay, because we cannot calculate the time of finishing, what's the estimated time to finish the project by adding the nodes, because they are not sequential, they have some relationships, some precedences. We have to take care of all of those, and then only then we can calculate the critical path, or we can calculate the the duration of the project and all, right? So we need to know what is event numbering. We have to compute, earliest start time, latest start time, earliest finish time, latest finish time, and we have to identify critical path and computation of slack or float. When we understand these, then our job will be easy when we do the PERTs and etc. Now in the event numbering, we have to number the event. So every event is identified by a reference number. Okay, there's a reference number for it, and like we saw in our diagram, network diagram, there are the numbers we gave it. We gave them either the random numbers, any number you like, some 3, somebody get 4, somebody get 5, or we get sequential like we did in a previous video, 1, then 2, then 3, then 4, and so on. The activity will be like this activity will be 1, 2, it will be named as 1, 2. Now this activity will be named as 3, 4, and the events will be named as 1, 2, 3, 4. That's called as a sequential. So the other terms, what I will use it for, to estimate the time of completion. Okay, so because the time estimates include the total time of completion, it needs the earliest start time at which the activity can start, given that its presiding activities must be completed first. Okay, there is this one. If you want to start this activity, these activities have to be first, so finish it. When these are finished, that will be its earliest start time for this activity to go. We will see them in detail in the example. If you're not understanding here, we will see examples and we will see what are these actually. Then there is an EF, earliest finish time. It is equal to the earliest start time for the activity. For this activity, for example, what is the earliest start time plus how much time it will take here to complete this activity. Okay, say up to this point we had 5 time and it takes itself 3. So earliest start time was the 5 for this activity to happen, and its own time is 3. 5 plus 3 is 8. That will be the earliest finish time. Now what is the latest finish time? The latest time in which the activity can be completed without delaying the project. What are these? We will see them in detail in example. And then there is a latest start time equal to the latest finish time minus the time required to complete the activity. What is the finish time? Latest finish time and minus whatever the time is of this activity. We have to minus them and to get what is the latest finish time. We'll see that properly in the example. I'm just giving you some idea about these terms, because these terms will be explained only with the help of example. Then you can understand it properly. Then there is a forward pass and backward pass and slack time. Okay, what are these also? We'll see it actually in example, because here without example you will not understand, and it's too much of time making this video. I took it's just a 21 minutes video maybe, but it takes a lot of time in getting the resources, then editing, then doing a lot of things to it, then uploading on YouTube, and then sharing it. It takes lots and lots of times. Okay, so that's all for today. Grab this much of knowledge, and I will be making the next videos with the examples of the PERT and CPM exactly. Now you are in a position to understand what is in a syllabus, because these 2 videos were only to build the basics. Okay, now the 3rd video will be actually which will help you in the exam. Okay, then see you next time. Ma salama.